Hi, in this video I'm going to explain the second example of related rates of change. Let's get to it. Here we have the scenario. It's two ships sail simultaneously from a harbor. One travels south at a velocity of 30 kilometers per hour, and the other ship travels east at a velocity of 40 kilometers per hour. After 2 hours, at what velocity are the ships separating away? I have here depicted the scenario. As you can see, I'm getting better drawing. So here is the first ship, the one traveling east, this x of t. Here is the other one, I named y of t. I'm not giving them these names because I'm getting a bit ahead of what I'm actually going to do now. Here, the most important thing to start out these kind of related examples, exercises, is just by asking what's the mathematical question behind it. How can we translate this to mathematics? So here is a small guide. I'm going to see what is the mathematical meaning of this question. Now the difference is a velocity of position over a difference of time. We should remember this from the physics courses or previous examples. Now consider the distance between the two boats to be c of t. That is to say, this distance separates both ships. We're going to call it c of t. C of t. Now, that is to say, C of t represents the distance that separates the boats in an instant t of time. Then what we are requested to find is actually the rate of change of this C of t after 2 hours. Now, the rate of change for C of t in any case would be, I'm going to write it here, would be C of t. If I take the derivative of this one, I'm going to write it here, derivative of c of t will be roughly dc over dt, which will represent the rate of change of this distance c, that represents the distance between the two boats, in time, with respect to time. So, well, let's try to find this out. But first we have to identify what is x of t and what is y of t. Now, the distance x of t is the one traveling to the east, which is this velocity, which is roughly a position time. As it is a position time, x, this is a very ugly x of t, this position will be determined by this velocity every hour. So basically we have the velocity of a, I'm going to give it the velocity of x would be more proper, velocity of x times the time. Let's say every hour it will move forward to the east 40 kilometers. So in other words, x of t will be equal to 40 kilometers per hour times the time here. I'm going to write it more nicely. There it is. Now let's get to y of t. I'm going to write here y of t would be roughly the velocity of the other boat, which would be b of y times t. In other words, would be y of t would be equal to 30 kilometers per hour times the time. Now we got x and y of t, but how can we relate this x of t, y of t, and c of t, which is the one we're looking for? We have to first find c of t in order to get to this dc over dt. Well, luckily we have our good old friend called Pythagoras that could help us out here. So I'm going to write down here. So we know that this relationship will remain all along. I'm just going to use a different color, will be this one. So c of t squared, which is the hypotenuse of this triangle, with this rectangle triangle, so we can use Pythagoras. So it will be c squared will be equal to x of t squared plus here will be y of t squared. Now we can substitute here a few things like x and the y functions. So we know that the x and the y, x is equal to this 40 times t. I'm just going to write the numbers because for simplicity's sake in this case, although the proper way will be to write everything out. So, but I'm just going to write the numbers just because I want to make this one quicker. And here we substitute x and y. Now we are going to, I'm going to write here this c of t squared quickly just to be very clear where we're standing in every case. Okay, there it is. Now this first 40 times t squared will be here in this case 1600 times t squared will be here plus, here will be 900 times t squared. As these have the same t squared, we can just add them together, add them up. Will be 60,000 plus 1600 plus 900 will be 2500 t squared. Now this is a c of t, but this c of t is a square, so we have to find c of t. Well, we have to square root both of these sides. I'm going to get the square root in both sides. Now we got c of t, we got here the square root of 2500 times t squared. So c of t will be equal to, this will be equal to 50 times t. So this is actually our c of t that we were looking for. So if we know already what c of t is, I'm going to continue over here in the center because we now know what c of t is. So c of t is equal to 50 times t. Now if I take the derivative of this, one, so in here, I'm going to get the c of t prime will be equal to this. I'm going to write it here below. The dc, it's equal, it's a very ugly c. This is better. Well, not so much. There it is. Well, dc over t, dt, will be equal to, derivative in this case, 5 times t will be only 5. We do not have to add any d something over d something because this is a function of time and we have here a t as a variable. So this is the dc over dt that we were looking for. Now this 50 has units. This has to be this is a rate of change of position over time, of distance over time. In this case would be kilometers per hour, kilometers per hour, and this is actually the rate of change that we were looking for. But here we have to look for, after 2 hours. Now here's a tricky question because this one has no variable, so this is a constant velocity, and you can see because the boats are not accelerating, they are moving all along with the same velocity. So if they are moving one to the east and one to the south with the same velocity, the distance that separates from them should be a constant number because they are not accelerated. The distance between them falls upon a very clean function, which is actually this one. So its rate of change remains just constant. In other words, I'm going to just write it c prime, in this case, would be, we are requested to find after 2 hours, c prime of 2 would be equal, in any case, to 50 kilometers per hour. And that would be the answer for this exercise.